All right, so here's an answer key for the review on mean value theorem and Rolles theorem. First of all, to use Rolles theorem, you need to check these preconditions. First, 1, the endpoints have to match. 2, f of x has to be defined on a to b, not including the endpoints. And 3, the derivative has to be defined on that same chunk. All right, so first let's check the endpoints. So to use Rolles theorem, you need to make sure that f of 2 is going to equal f of negative 2. Well, let me do negative first. Okay, I want to see if that endpoint there, that x value is going to end at that one. So, because Rolles theorem says if you start and end at the same height, there must be a place where there's a max or a min. Okay, so let's type in a negative 2. So you're going to go negative 2 to the 4th minus 4 times negative 2 squared. Okay, and then on the other side, we're going to go 2 to the 4th minus 4 times 2 squared. Okay, so 2 to the 4th is 16. The negative gets killed off. Minus 4 times 4, 16. This side, same deal. We get 0 and 0. So check. Endpoints work. The second thing is f of x defined. And that means, are there any holes or asymptotes? Since there's no fractions or radicals, I don't have to worry about that. And the derivative defined. I should probably find the derivative first, right? This is an easy one though. 4x to the 3rd minus 8x. No fractions, no radicals, so no holes, no asymptotes. So all those were the preconditions. After that, Rolles theorem says if you meet all of those preconditions, it guarantees there must be a max or min somewhere on this chunk of the graph for this graph. How do you find it? Well, you find when the derivative is 0. So I set f prime of x equal to 0, and I'm going to solve that. So this is a pretty easy solve, especially if you know how to factor, which, you know, let's hope, right? So we got, if you take 4x out of there, you got x squared. If you take 4x out of here, you got minus 2. So either 4x equals 0, or this thing equals 0, and you solve it, plus or minus radical 2. Now, you might keep all these answers, you might not. They have to fall on this interval. So if you remember, that's about 1.41 plus or minus. Do all of them fall between there and there? Yep, so we got these and these as your maxes and mins. So this is a graph that kind of squiggles along. All right. All right, so the next one is use the mean value theorem to find C on the interval from negative 2 to 4 for this equation. Remember, in order to be able to use the mean value theorem, you got to pass these two tests. Now, they're the same two as these. You just don't need the endpoints to match to use the mean value theorem. So I want to check, is f of x defined? And that's a yes, because this doesn't have any fractions, it doesn't have any radicals, so I'm not worried about that. I want to check, does my derivative, is my derivative defined the whole time over this section? And technically, it doesn't have to even be defined at the two endpoints, but it passes both tests. Now that it passes both tests, you want to find all values of C when the average slope equals the instantaneous slope. So the instantaneous slope is f prime of x. And the average slope is f of b minus f of a over b minus a. So it's pretty easy to do. Average slope is just y minus y over x minus x. So we're going to do that. What is f of 4 and f of negative 2 over 4 minus negative 2. And I'm just going to plug in this 3x squared. So we'll get the left side to turn into a number, and then we'll solve it. Okay, so this is my instant slope. My average slope is just here. So what's f of 4? Well, if I plug a 4 in to the original equation and I cube it, 4 times 4 times 4 is 64, plus 1 is 65. And then if I put a negative 2 in here, negative 2 cubed is negative 8, plus 1 is negative 7. Ooh, but it's minus a negative. Careful on that. Bottom's a 6. 65 minus negative 7, which is the same as plus a positive, going to leave you with 72. Right? Then if we do 72 divided by 6, we're going to get 12. Then we solve this equation. So x squared is, so divide by 3, x squared is 4, and x is plus or minus 2. You make sure both of them are on your section there. Let's check our interval up here between there and negative 2 and 2. Negative 2 is actually on an endpoint, and mean value theorem is looking for numbers between negative 2 and 4. So you actually, even though the answers are positive and negative 2, we only keep the positive 2 because it's actually between those two numbers. We throw out the negative 2 because it's an endpoint. We actually only want answers between them. Same up here. If I would have gotten an answer of 2 or negative 2, I would have thrown it out. So basically, this is the point on your graph where the average slope equals your instantaneous slope. All right, so for this one, first you got to make a change to the problem to be 2 radical 3. For some reason, I wrote down 4, which I don't know why. But if you do that, if you type in a 0, you get 0 as an answer. If you type in a 2 radical 3 in parentheses, so if you did 2 radical 3 cubed minus 12 times 2 radical 3, you get 0 also. So the endpoints match up. If you used a 4, you just wouldn't do this problem and say Rolles' theorem doesn't apply because the endpoints don't match. Is f of x defined? Yes. And is f prime of x defined? Well, let's check. We should probably find f prime of x. 3x squared minus 12. There's no fractions, no radicals, so we're cool on that. So it passes all the tests, which means I should be able to find at least one place where the derivative equals 0 on my interval. Let's solve that. So we got 12, 3x squared, x is 4, x equals plus or minus 2. Once again, I probably won't keep both these answers because negative 2 doesn't fall on that interval, so there's my winner. If you would have done this problem with a 4 there, you would just say Rolles' theorem doesn't apply because it doesn't start and end at the same height. So there's either a max or a min right there. All right, now our last one. Oh, sorry, our last normal one. These two are weirder. So we want to find when does the average slope equal instant slope. And first we have to take the derivative. And then we have to also check, I want to check when, I need to check is it defined on f of x, is f prime of x defined? And f of x is defined because there's no fractions or anything, f prime of x defined, so that works. Now my average slope is f of b, which is 3, minus f of a over b minus a. And I'm going to set that equal to my instant slope and solve it. So let's see, what's f of 3? If I put a 3 here, 3 cubed is 27, minus 9 times 3, that's 0, minus 0 over 3, which is 0. And then I go to solve this guy, take the 9 to the other side, divide by 3, and you get x squared is 3, so x is plus or minus radical 3. Do I keep both those answers? Probably not. Radical 3 and negative radical 3. This one's not on my interval, so this is the place where the average slope equals the instant slope. Okay, so now we have this one, and what condition does it fail? Does it for mean value theorem? So mean value theorem only has to have my original function defined and my derivative defined. So I want to check, is this function defined for everywhere between -3 and 1? And if you check, if you put even a 0 in here, so I'm checking is f of x defined? If I put a 0 in here, I could try any point on here, but if I tried x equals 0, you're going to have the square root of 0 squared minus 4, also known as square root of -4, that's undefined. So this fails because f of x is not defined on -3 to 1. If you would have plugged a -3 in, it would have worked. But if you would have, -3 squared is 9. If you would have plugged a 2 in, it would have worked. But you plug a 1 in, or a 0, and it's not going to work. Now, as soon as you find one reason, you don't have to check the other. I bet that f prime is also not defined, but I don't have to check f prime because it already failed. And once it fails once, it fails for good. All right. Rolles theorem, you have to check the endpoints. Let's see. Endpoints, if at the beginning, f of 0 and f of 4. So if I put a 0 in, I get 0. If I put 4 in, I get 0. Okay, so endpoints work. Like I said, if that would have failed, I would be done. I want to check, does f of x defined? And with a fraction, I'm concerned with when the bottom equals 0. That's when it's undefined. So when is the bottom equal to 0? At x equals 2. Is that on here? Yep. I'd say it's undefined at x equals 2. F of x is undefined. So that one failed for both reasons. Its derivative also would have been undefined too. So anyway, hope that helps. One type of problem I didn't have in here that I would like to is a problem that looks like this for a mean value theorem or a Rolles theorem, where you have to take the quotient rule or something like that. All right, hope that helps. Talk to you later, people.